Good afternoon, students. Uh, Today we had this is the ninth video. Uh, Last video we see that we derived the reversible isothermal expansion of an ideal gas. Reversible and isothermal expansion of an ideal gas. And in that video, we also last class we derived the work done and also the internal energy. We know that internal energy is a function of temperature. Internal energy is a function of temperature at dt is equal to 0, then internal energy will be 0. So work done, we already derived this equation. W is equal to minus 2.303, that was the log V2 by V1. You see that video, we derive the equation W is equal to minus 2.303 nRT log V2 by V1. nRT minus 2.03 nRT log V2 by V1. This what done is derived. Then we also know that in that cases what we did also, the change in internal energy, as we know that U is a function of temperature in case of ideal gas only. So isothermal means dt is equal to 0. So at dt is equal to 0, U delta U also is equal to 0. These two things we derive in that video. Today we have to derive the heat and the enthalpy. So that was the call as what? Now isothermal reversible expansion of ideal gas. Okay, these two things we already derived. Today we have to derive the what? Na Q. Del Q is equal to du minus W from the first law of thermodynamics. From the first law of thermodynamics that we know, thermodynamics. Minus W means work done by the system. Du means change in internal energy. So your Q is equal to du is equal to 0, del U is equal to 0 at constant temperature. Isothermal process, temperature constant. Isothermal means dt is equal to 0. So dt is equal to U is a function of temperature in case of ideal gas only. This is for ideal gas only. It is not applicable for van der Waals gas. It is applicable for ideal gas. So your U is a function of temperature, and dt is equal to 0, del U is equal to 0. So I put here du is equal to 0, then minus, and W is equal to, this is minus, then W is equal to minus 2.303 nRT log V2 by V1. Minus will be plus. 0 plus something is equal to same this much, 2.303 nRT log V2 by V1, and this is nothing but heat. Q is equal to 2.303 nRT log V2 by V1. This is the expression for heat. Okay, now next is expression for H. Next is expression for H, enthalpy. This is the expression for Q. Expression for Q, heat. Now we have to discuss about expression for H. What is the formula for H? We know that delta H is equal to delta U, delta H equal to delta U, P delta V. This is the ideal gas. We consider P delta V is equal to delta N RT. Instead of P delta V, I can write delta N RT. So this is equal to delta H is equal to delta U plus delta N RT. We know that in that cases, in previous cases, in that means in Van der Waals case, what we do? Now we take PV2 minus PV1. In that cases, the pressure we derive from the Van der Waals gas, but it is the ideal gas. So in ideal gas, P delta V is equal to delta N RT. That means it is in terms of ideal gas. Okay, that is why instead of P delta V, I write delta N RT. So it is isothermal. Remember, isothermal means dt is equal to 0. That means T is equal to 0 means this entire portion will be 0. Delta U, we know U is a function of temperature in case of ideal gas. So dt is equal to 0, delta U is also equal to 0. Now substitute this value here. We get what? Now delta H is equal to 0 plus 0 is equal to 0. That means delta H is equal to 0. That means there is no change in enthalpy. So there is no change in enthalpy. Delta U also equal to 0. We know expression for. So there is no change in internal energy. There is no change in enthalpy. This is happen in case of reversible isothermal expansion of ideal gas. And work done, we already derived minus 2.303 nRT log V2 by V1, or P1 V1 is equal to P2 V2, V2 by V1 is equal to P1 by P2. Instead of this, you can write P1 by P2 also. The pressure is given to you. We already derived this one. So W is equal to this much, Q is equal to this much. This is the isothermal reversible expansion of ideal gas. Now we have to derive the isothermal irreversible. Already we go reversible. Now we have to derive irreversible. Isothermal temperature is constant. That means isothermal irreversible expansion of ideal gas. Isothermal irreversible expansion of an ideal gas. Irreversible, remember. That was the reversible. Reversible means maximum work that we can derive. Maximum work that we can derive. But irreversible case, that means irreversible means whatever we do in our nature. Whatever work you do, all are irreversible. Whatever the process you carry out, all are irreversible. Reversible only a theoretical concept. We cannot get a reversible process. It is only theoretical concept. But whatever you do process in your day-to-day life, all are irreversible. All natural processes are irreversible. Okay. Now we have to see that what is the expression for W. Expression for W, work done. That means we know that it is expansion, low volume to higher volume. That means work done by the system. That means Patina, this is my piston. Suppose initially this is my V1, this is my piston. When work done by the system will do, this piston will move upwards here, and this is equal to V2. Piston moves from here to here. Then what is the distance covered? Now V2 minus V1, and this portion is V2 minus V1. This is the work done. That means we know that work done by the system means minus P external dV. That means here P dV means minus P external V2 minus V1. This is the work done. This is the work done by the system. Irreversible process. If you draw the diagram for irreversible process, then what you get? This is the PV diagram we derive. This is the pressure. This is the volume. This is the in y-axis. This is in x-axis. This is in y-axis. Same process in case of expansion. That means this thing you will derive. This thing is that. Here initial volume is V1, final volume is V2. It is expansion. And in case of reversible, what is the work done? Now the entire portion. In case of reversible, remember, entire portion. But in case of irreversible, what is the work done? Now work done only this much. It is less than that of the reversible process. This is the only the work done. That means this much amount is less from that of the reversible, because reversible is a theoretical concept, but in this case we get actual work is this much we have to carry out. This much amount is wastage due to friction. Due to friction, if we put gas here, they have force of attraction between the gas molecules. So in this cases what happens? Now this is due to friction. This much amount of energy waste we have to waste. So this is the irreversible process in case of expansion. So in this cases, what is my work done? Now work done is equal to minus P external V2 minus V1. This is the work done by the system. Work done by the system. Suppose work done when this is expansion. When we undergo a compression, what do we do? Now in case of compression, what do we do? Now in case of compression, same graph. It is in x-axis, it is in y-axis, it is pressure, it is the volume. Same, but it is compressed. It is compressed. That means this is V2, this is initial. From higher volume to lower volume we will come. This is the final. In case of expansion, this is initial, this is the final. But in this case, this is initial and this is the final. It is compressed, arrow is that side. And work done is this much. Less than that of the reversible process. Less than that of the reversible process. Okay, that means this much amount is wasted. This much amount is wasted. That means work done is equal to work done on the system. It is positive. So P external final volume is V1 minus V2. This is the work done. This is the work done. This is the work done on the system. This is the work done on the system. Okay, this is compressed. So always remember, work done in irreversible process, work done in irreversible process, work done in irreversible process, work done in irreversible process is less than the reversible process. Because in irreversible process, external pressure is less than the pressure of the gas. In case of irreversible process, this is the condition. External pressure means top pressure is less than that of the gas pressure. But in case of reversible process, but in case of reversible process, external pressure is equal to pressure of the gas. In case of reversible process, reversible condition, what happens? External pressure is almost equal to the gas pressure. Okay, that is why in the irreversible process, work done carried out is less than that of the reversible process. Reversible process is only theoretical concept, but in case of whatever the process you carried out, that was all about the irreversible process. Then expression for W, you get this much. Then expression for U. Expression for U. You know that in ideal gas, U is a function of temperature. At dt is equal to 0 because isothermal. Dt is equal to 0 because isothermal. It is isothermal. Temperature is constant. At dt is equal to 0, del U is equal to 0. That means here there is no internal energy change. Del U is equal to 0, just like in the reversible process. In the reversible process also, del U is equal to 0. In this case also, irreversible process also, delta U is equal to 0. Then expression for Q. Expression for Q. From the first law of thermodynamics, del Q is equal to du minus W. Minus W means work done by the system. So this is equal to del Q is equal to du is equal to 0 minus W. W is equal to minus P external V2 minus V1. Make it square bracket, then in the parenthesis. This one minus is equal to plus. That means Q or del Q is equal to P external V2 minus V1. This is the expression for Q. This is the expression for Q. In that case also, reversible process, whatever be the work done, that was the only reverse sign. In this case also, it is negative here, it is positive. In that case also, work done is negative, minus 2.303 nRT log V2 minus V2 by V1, and in the Q also plus 2.303 nRT log V2 by V1. Whatever is here minus, here only sign is changed, no other thing. Then expression for H. Expression for H, same, no change. Expression H means we know that delta H is equal to delta U plus P delta V. The gas is ideal. So in case of ideal gas, what happens? Now P delta V is equal to delta N RT. Delta N RT. Now substitute this value here. We get what? Now delta H is equal to delta U plus delta N RT. Temperature, there is no change. R is constant. N is also number of mole change. So at dt is equal to 0 because it is isothermal. It is isothermal. Dt is equal to 0. Then del U, we also know that U is a function of temperature. At dt is equal to 0, del U also is equal to 0. Substitute this value, then delta H is equal to 0 plus 0 is equal to 0. That means delta H is equal to 0. There is no enthalpy change. Same as that in case of reversible process. In reversible process also, this delta U is equal to 0, delta H also equal to 0. In reversible process. And in irreversible process also, delta U and delta H both are 0. Okay, this is the isothermal irreversible expansion of an ideal gas. Then isothermal free expansion. Then isothermal free expansion of ideal gas. Free expansion, isothermal free expansion of ideal gas. Expression for W. Expression for W. So work done by the system. So work done by the system means my formula is equal to minus PdV, or which we can write as W is equal to minus P external V2 minus V1. In case of free expansion means vacuum. Vacuum means P external is equal to 0. P external is equal to 0 because vacuum means free expansion. External pressure is equal to 0. When external pressure is equal to 0, now substitute this value is equal to 0 here, then we get W is equal to minus 0 into V2 minus V1. When you multiply with something 0, then value will get 0. So work done is equal to 0. That is, no pressure volume work is possible. No pressure volume work is possible in free expansion. No pressure volume work is possible in free expansion. No pressure volume work. That means in this case no work done. Free expansion. Then expression for U. Expression for U. Expression for U. Internal energy. We already know that U is a function of temperature in case of ideal gas. So it is isothermal. That means dT is equal to 0 because condition is isothermal. There is no change of temperature. At dt is equal to 0, then delta U is also equal to 0. Delta U also equal to 0. That means there is no internal energy change. No work done. W is equal to 0. Internal energy change also equal to 0. Then expression for Q. Expression for Q. From the first law, we know that Q is equal to delta U minus W. Minus W means work done by the system. Okay, delta U, the change in internal energy. If you put the value delta U, we know 0, work done also 0, 0 minus 0, that means is equal to 0. That means Q is equal to 0. There is no heat exchange between the system and the surrounding. So Q is also equal to 0. Double 0, Q0, U0. Then expression for H. Then expression for H. H is formula is delta H is equal to delta U plus P delta V. In case of ideal gas, P delta V is equal to delta N RT. It is in case of ideal gas. Now substitute P delta V by delta N RT, we get what? Now delta H is equal to delta U plus delta N RT. Process is isothermal. dt is equal to 0 because it is isothermal. delta U also equal to 0. Delta U is equal to 0 because U is a function of temperature. In case of ideal gas, U is a function of temperature. Now substitute the value in there, we get delta H is equal to delta U 0, then delta N RT also equal to 0, 0 plus 0 is equal to 0, so delta H is equal to 0. That means in free expansion, external pressure is when external pressure is equal to 0, that means in vacuum, when expansion occurs in vacuum, then in that case what happen? Na double 0, U0, Q0, H0, all 0. Okay, this is the in case of isothermal cases. Now we will go for adiabatic process. In adiabatic process, तो कुआड आसुचु रे काई तो आसुचु ये सुफा कली तो काई आसुचु धनटा तो बायाटा लो जा पड़ा जा लो जा ना धनटा मोर मो धन जा डेई पड़लु टिके जा तो कहूँ तू जा कहीं हाँ बास जा लो जा तू बन्य जंतुटा आम सागे कहीं तू सांग बांधुचु तो घर अलगा मो घर अलगा जा आउटे आगू पड़ा कबाट दे दिए जा लो धनटा मो धन जा लो धनटा पड़ा जा उठके जा हाँ वाह जा कबाटा दे दिए. Then next start. Then in adiabatic process, adiabatic process means this is all are in the isothermal process. In the isothermal process, we carried out van der Waals gas, and also in isothermal process we carried out the ideal gas. Now in adiabatic means no heat exchange, only work can exchange. Adiabatic reversible expansion of ideal gas. Adiabatic reversible expansion of ideal gas. In this case, what we do? An expression for W. Expression for W. So work done by the system, expansion means work done by the system, it will become negative minus P external dV. This is the work done, external pressure. In adiabatic process, what happens? Now PV to the power gamma is equal to constant. In case of ideal gas, gamma is equal to 1. In case of ideal gas, that means ideal gas gamma means Cp by Cv. Gamma means Cp by Cv. Gamma is equal to Cp by Cv. In case of ideal cases, Cp is equal to Cv. So that means gamma is equal to 1. When gamma is equal to 1, then it becomes ideal. But in that cases, what happens? Now Pv to the power gamma is equal to constant in adiabatic process. In adiabatic process, that means it indicates that Cp by Cv is not equal to 1. That means Cp by Cv or gamma is, in case of diatomic gas, 1.6, then 1.4, then 1.3 triatomic gas. Monoatomic gas is 1.6. Diatomic gas is 0.2 less, 1.4. Triatomic gas is 0.3 less, 1.3. Triatomic gas. That was the gamma value we have to put there in adiabatic process. Then in adiabatic, then what we do? Now P is equal to C V to the power gamma. Substitute this value of P in this equation. We get what? Now W is equal to minus C V to the power gamma dV. Now volume undergo expansion V1 to V2 adiabatically. V1 to V2 expansion is occur. That means expansion means such like, suppose this one is equal to V1 initial volume, this is the initial, it undergo expansion, this one, this is the final V2, this is the final, that means V1 to V2 expand, then what is the work? Now V2 minus V1, so that is why that was the dV. Then we have to make integration, of W and d V1 to V2. That means if you take del W, then you get W2 minus W1, that means W is equal to, or del W, whatever change in volume, is equal to C is constant, takes outside, integration V1 to V2, C is constant, comes outside, dV to the power V to the power gamma. When V to the power comes upward, W is equal to minus C integration V1 to V2, V to the power minus gamma dV. Then when you take the integration, minus gamma plus 1, then W is equal to minus C V minus gamma plus 1 divided minus gamma plus 1 is V1 to V2. Now substitute the upper limit first, then lower limit, then W is equal to minus C bracket V2 minus gamma plus 1 divided minus gamma plus 1 minus V1 minus gamma plus 1 divided minus gamma plus 1. Okay, take minus gamma plus, that means minus gamma plus 1, that is no limit. Oh, sorry, V1. Take, okay. That means you take minus gamma plus 1 common, we get what? Now W is equal to minus C divided minus gamma plus 1, take common, we get what? Now V2 minus gamma plus 1 minus V1 minus gamma plus 1. Okay, this is one of the formula. Then we know that you can convert this, that means we know that P1 V1 to the power gamma, P2 V2 to the power gamma is equal to C. Now you multiply C in that every cases, then your W is equal to minus 1 by gamma plus 1, minus gamma plus 1, take common, you get C V2 minus gamma plus 1, then minus C V1 minus gamma plus 1, no problem. Now C is equal to P2 V2 to the power gamma. In this case, V2 to the power gamma plus 1, it is easy for me if I put P2 V2 to the power gamma instead of C, and in this case P1 V1 to the power gamma. Okay, if we put this value, then W is equal to minus 1 by gamma plus 1 minus gamma plus 1. In place of C, I write P2 V2 to the power gamma V2 minus gamma plus 1, then minus P1 V1 to the power gamma V1 the V2 V1 minus gamma plus 1, minus gamma plus 1, this is the bracket in. Then W is equal to minus 1 by minus gamma plus 1, देखा जाऊँगी ना नहीं, minus gamma plus 1, if you take common, minus 1 by minus gamma plus 1, here we can write P2 is same, here is, that means V2 base is same, plus gamma minus gamma, then V2 is equal to plus gamma minus gamma plus 1. Similar, in this case base is same, P1 V1, base is same, V1 V1, gamma minus gamma plus 1, plus gamma minus gamma cancel, ये मतलब gamma cancel, we get what? Now W is equal to minus 1 by minus gamma plus 1, we get P2 V2 minus P1 V1. This is the work done in adiabatic process of an ideal gas. As the gas is ideal, we know that P2 V2 is equal to RT2. I can write PV is equal to nRT, N is equal to 1 mole, PV is equal to RT2. Similarly, P1 V1 I can write RT1. So instead of P2 V2 I can write RT2. Instead of P1 V1 I take RT1. Substituting this value we can get another equation minus 1 by minus gamma plus 1 is equal to RT2 minus RT1. Take R common. Now W is equal to minus R minus gamma plus 1 of T2 minus T1. This is the another work done formula of R minus gamma plus 1 T2 minus T1. Okay, if we do the pressure volume diagram, this is the pressure, this is the volume, this is the x-axis, this is the y-axis. If this is for expansion, for isothermal, suppose this is for isothermal, adiabatic is slightly less than that of isothermal. This is expansion. This is the expansion. This is for adiabatic. Second, Adiabatic. Second one is adiabatic, first one is isothermal. Adiabatic slightly less than that of the isothermal. Whatever the value of isothermal, adiabatic slightly less than that of the isothermal. So this is case of adiabatic, we get this one, lower one. Similar also in compression. Reverse, that means you make this one to this one, it will go off. You make it clockwise rotation, it will go off. Then adiabatic up, isothermal down. This is what happens in case of PV diagram for adiabatic work done. Okay, what is the time already? In the next class we will tell. Yes, okay, I stop here. So in the next class we will do some other expression for Q. घरे बसी सब पढ़ब कहीं सबुआडे कोरोना बाहर जन गवर्नमेंट सबुआडे बाघ फाग छाड़ी बाघ सिंह उभे छाड़ी सबुआडे 3-4 दिन है से मैंने खाई ना नंदनकानन आस322 बाघ आउ शिमिलीपाल आस221 सिंह सब गाँव में छड़ाई बाहर बुलियो बोले धरिकी पलैबे कतई टीवी भी देखनी खाली बस पढ़ बही खाता 24 घंटा टीवी देखिले बाघ धरिकी पलैब तुम घरे पशिकी नहीं पलैब देखिए से पाठ पढ़ा पिला खाइबनी केवल पाठ जी न पढ़ुव ताकू धरी से पलैब खाईदेव ताक भोक लगुच से खाई ना छेली खाती तेणु से मनीष खाली खाइबे मनीष मरा से गुड़ा सब आसुँच हौ।